So in section 6.4 part 2, we'll take a look at how to calculate a permutation and also how once you read a word problem or the application problem to determine it is a permutation. So consider a club that has 10 members that want to elect a president and a vice president. Order is important. The first person picked will be the president and the second person picked will be the vice president. No repetition is allowed because the same person can't be both president and vice president. And then again, they're distinguishable. You can tell the difference between the two people. So in that case, we would take literally 10 choices for the first person times 9 choices for the second person, and that would give us 90 possibilities. Now, in terms of an actual formula, this is considered a permutation. So I can calculate it the way we just did, but if the numbers are bigger or you're picking more of them, it gets to be cumbersome. So instead, a permutation of, and the way we're going to write it is the permutation of n objects taken r at a time. So this is the total number you're picking from. Total picking from. And then the r is the number you are picking, so the number chosen. So choose r objects. So the larger number always goes first. And that just happens to be n factorial, which is why we needed that factorial key, all over n minus r factorial. So there is a formula for it. Luckily for us, our graphing calculators have this built in already, so we don't need to memorize the formula, but you can now see why you might need that 0 factorial. If you have 10 objects and you're picking all 10 of them, then this would be 10 minus 10 or 0 factorial, which is why it's defined to be 1. So now we're going to get some practice on the calculators using this. You're going to find it in the same spot we did the other one. So you're going to go to math, then over to PRB for probability. Then you're going to go down 1, 2 should be NPR. So you're going to pick number 2. So let's go do the exact same problem we just did. So let's do this is example 3. We're going to do the permutation of 10 objects picked 2 at a time. Again, this is 10 objects picked or chosen 2 at a time. Okay. So on your calculator, the very first thing you're going to do is type in the 10. Then go to math, probability, down to number 2. So again, 10, and then you're going to do NPR, and then you're going to type in the 2. And then finally hit enter. And your calculator will go off and do this calculation for you, and you should get that same 90 that we did a few minutes ago. Now, I agree that in this case, 90 is a lot easier to find by taking 10 times 9. But again, when the numbers become cumbersome, we can definitely use the calculator. The next example is the permutation of 10 objects chosen 8 at a time. So pick 8 of them at a time. So again, going to the calculator, typing in the 10, then NPR, and then 8, you're going to find that's a lot more possibilities. That's 1,814,400 possible ways to have 10 people and pick 8 of them at a time. Or to arrange a pile of 10 books, pick 8 of them and put them on the shelves. The next one asks us to do, sorry about that, the permutation of 12 objects picked 1 at a time. Well, if I only have 12 to pick from and I only have 1 choice box, then I literally have just 12 possibilities, 1 for each of them. Then what if I want to do all the objects? So 7, choose 7. So 7 objects picked 7 at a time. There's more of that because you have 7 and then 6 times 5. We saw this just a few minutes ago. This comes out to be that 5,040. So there's a big difference between picking 1 of them and picking all of them. Okay, so in terms of words, how are you going to determine when order matters? So each of the next examples gives you an example of when the order that you're arranging the objects in matters. So example 4 says there are 8 horses entered in a race. In how many ways can first, second, and third place be determined? So because we are ranking them and giving them a title as we cross the finish line. So ranking means they get a title, first place, second place, third place, that kind of thing. So this would be the permutation. We have 8 horses and we're picking 3 of them to cross the finish line in first, second, and third place. So the permutation of 8 choose 3 comes out to be 336. Now again, we're not looking at the skill level of the horses, the skill level of the jockey, anything like that. So if all things are weighted equally, then there are 336 ways that those top 3 finishers can cross the finish line. Example 5 tells us that 15 candidates were interviewed for a job at the university. How many ways can the top 5 be ranked? So it literally says be ranked. So your first choice, second choice, third choice, again, you're giving them a title. So we know that we have 15 candidates and we are picking the top 5. So that would be the permutation of 15 objects chosen 5 at a time. Heading to your calculator, that should come out to be 360,360. It's a lot of ways to rank those top 5 candidates. Example 6 says, find the number of ways in which a chairman, vice chairman, secretary, and treasurer can be chosen from a committee of 9 members. So as I'm picking them, I am giving them a title. So chairman, vice chairman, secretary, and treasurer. So because they are getting a title, it's a permutation and order matters. So we know all together that we have 9 members on our committee. We're picking the top 4. That would be chairman, vice chairman, secretary, and treasurer. So there's 4 altogether that we're picking. That's 3,000. So anytime that the order matters, it's a permutation.